In this paper, we present the Spatio-Temporal Deformable Attention Network for video deblurring. Let me start with the problem definition of video deblurring. We need to input multiple consecutive blurred video frames and then use a neural network to aggregate multiple frames to restore the sharp frame of the middle frame. Unlike image deblurring, video deblurring methods exploit additional information in the temporal domain. The key success factor of video deblurring methods is to compensate for the blurry pixels of the mid-frame with the sharp pixels of the adjacent video frames. Therefore, mainstream methods align the adjacent frames based on the estimated optical flows and fuse the alignment frames for restoration. However, these methods sometimes generate unsatisfactory results because they rarely consider the blur levels of pixels, which may introduce blurry pixels from video frames. Here is a motion blur case. In the I frame, the man riding a bicycle is sharp. However, the same regions are blurry in the I-1 and I+1 frames. In the figure, we use different color bounding boxes to highlight same regions in 3 frames. In contrast, the green and yellow bounding box regions are sharp in the I-1 frame and blurry in other frames. Therefore, not all the pixels in video frames are sharp and beneficial for deblurring. To address this problem, we propose Spatio-Temporal Deformable Attention Network, STDA-NET, which extracts the information of sharp pixels by considering the pixel-wise blur levels of the video frames. Specifically, STDA-NET is based on an encoder-decoder network combined with motion estimator and spatio-temporal deformable attention, STDA, module. First, the encoder extracts the multi-features from multiple input frames. Then, the motion estimator predicts coarse optical flows between consecutive video frames given the multi-features generated by the encoder. After that, the estimated optical flows and the extracted features are fed to STDA module to generate the fused features by aggregating the information of the sharp pixels from the extracted multi-features. Finally, the decoder restores the sharp mid-frame based on the fused features. To extract the information of sharp pixels from consecutive video frames, we propose Spatio-Temporal Deformable Attention, STDA, module. There are 2 layers in the STDA module that aggregates features in a coarse-to-fine manner, named multi-to-multi attention layer and multi-to-single attention layer. We employ 2 loss functions to train STDA-NET. MSE loss represents the distance between the restored frame R and its corresponding ground truth sharp frame S. Warp loss is introduced to train the motion estimator in an unsupervised manner. In total loss, gamma controls the weights of the warp loss. Here's the qualitative results on DVD, GoPro, and BSD datasets. The proposed STDA-NET recovers better details than other methods. Here's quantitative results on DVD dataset. Our method outperforms other competing methods. Here's quantitative results on GoPro dataset. Our method outperforms other competing methods. Here's quantitative results on BSD dataset. Our method outperforms other competing methods on the 3 sub-datasets. Here's the demo of our method. Thank you for watching.